Okay, ladies and gentlemen of algebra, this is Unit 6, Notes 3, talking about exponential decay. Remember, in this unit, it's everything exponential. So wherever there is an exponent, that is the variable. So we're talking about exponential decay. That means things are decaying. That means things are falling apart. So very similar to exponential growth. Remember, exponential growth, you had C1 plus the rate to a time t. Now you're just flipping it around and saying your rate of decay is going to be subtracted from 1. All right, so the main thing you raise to an exponent better be smaller than 1. All right, so if I take a look here, C is 16, R is 45.45. So that's saying your initial amount is like 16 pounds or something, or 16 grams or something, and it's got a rate of decay of 0.45. So I'm going to take 1 minus 0.45 raised to the t. So what that means is I'm going to have 16 times 0.55 raised to the t. All right, so t is like x. So if I go 0, 1, 2, 3, 4, this is what I'm going to end up with. So at 0, I'm going to be at 16. At 1, I'm going to be at 8.8. At 2, I'm going to be at 4.84. At 3, I'm going to be at 2.662. And at 4, I'm going to be 1.4641. Now, please remember, the exponential function, the one that looks mostly like this. Well, now, because it's decay, it's going to look more like this. All right, I'm going to start off really, really high, then come out and kind of bottom out. I'm never actually going to hit 0. I'm just going to keep getting closer and closer and closer. So at 0, I'm at 16. At 1, I'm at 8.8. At 2, I'm at 4.84. 3, I'm at 2.662. 4, I'm at 1.4641. So this is going to come down and bottom out, never actually touch 0, but get really, really close. All right, so if I get C is 15, R is 1/3, so that's going to be 15 times 1 minus 1/3 raised to x. So this is going to be 15 times 2/3, or 0.6 repeating if you want to put that in your calculator, and that's going to be what you're looking at. So if I look at 0, I'm at 15. At 1, I'm at 10. At 2, I'm at 6 2/3. At 3, I'm at 4 4/9. And at 4, I'm at 2.963. So 0, I'm at 15. 1, I'm at 10. 2, I'm at 6 2/3. 3, I'm at 4 4/9. And by the time I get to 4, I'm all the way down here at 2.962. So this is going to be a little bit more broad, but it's still going to look kind of that same idea. Right? It's never going to touch 0, but it's just going to get close. So a fully inflated raft loses 6.6% of its air every day. The raft originally contains 4,500 cubic inches of air. Write an equation to represent the loss of air using general equation for decay. We'll cross off that D there because that shouldn't be there. So C is going to be 4,500. Our original amount is going to be 4,500. My rate is 6.6%, but as a decimal, move it over 2 places, that's going to be 0.0066. So my equation is going to look like this. All right, simplified, it's going to be 4,500 6 0.9934 T. All right, so that's air every day. So after 7 days, so if T equals 7, so I'm going to put 7 in there, raise that to the power of 7 times 4,500. So after 7 days, I'm only going to have 4,296.17 cubic inches of air. All right, during the past several years, the population of Campbell County, Kentucky has been decreasing at an average rate of 0.3% per year. 2000 population was 88,000. Write a decay equation that represents the population since 2000. Then figure out the population in 2013. So C is going to be 88,647. My rate of decay here is 0.3%, which as a decimal is 0.003. So which means my equation looks like this. 1 minus 0.000 or 0.003, apologies, to a time of t. Now, t is years in this case because we're talking about a population, and we're talking about how much has it dropped off in 13 years. So t is going to be 13. So I'm going to have 88,647. Then 1 minus 0.003 is going to be 0.997. And t is going to be raised to the 13th power. So throw all this into a calculator. And after 13 years, you're down to 85,251 people, roughly. You're going to have a decimal, but we're talking about people here. You can't have a decimal of a person. So you're talking about roughly 85,000 people. So during an economic recession, a charitable organization found that its donations dropped by 1.1% per year. Before the recession started, the donations were 390,000. Write a decay equation representing the charity's donations since the beginning of the recession. Then estimate the amount of donations 5 years after the start of the recession. So my initial amount, 390,000, that's going to be my C. My rate is going to be 1.1%. As a decimal, that's 0.011. Let's change colors. Let's do that. So this is going to be 390,000. 1 minus 0.011 raised to the power of t. Now, t in this case is going to be 5. So I'm going to have 390,000 0.989 to a power of t, and t is going to equal 5. So raise that to a power of 5, multiply by 390,000, and I get that 5 years down the road, the donations are going to be roughly $369,000 and $369,016.74. All right, determine the following are growth or decay. Okay, so the big tip off here, what I'm looking at is what am I raising to the exponent? If I'm raising something bigger than 1, it's going to be growth. If the number I'm raising to a power is smaller than 1, it's going to be decay. So if I look at this one, number 1, I'm raising 7 to x. It doesn't matter that this is minus 0.5. If I put in like 7 to the 5th, that's going to be some really, really huge big number. This is going to be growth. Even this one, follow order of operations. I do this part first. 4 raised to the exponent is way, way bigger. This is going to be bigger than 1. This one's going to be growth. I'm only looking at what am I raising to a power. So for this one, number 3, 2/5 gets raised to the power. Not 5, I don't care about 5. 2/5 gets raised to the power. That's going to be decay. For number 4, 5 gets raised to the power. That's bigger than 1. That's growth. And this last one, number 5, I don't care about the 2. I don't care about plus 3. I'm only looking at 0.75. That's going to be decay. All right, thank you for your time. Please get going on your work and let me know what I can help you with. Thank you very much.